So now that we know how to add and subtract numbers to inequalities, let's see what happens when we multiply or divide numbers to inequalities. First of all, let's make sure this inequality is true. Is 2 less than 4? Yes, 2 is less than 4. So what happens if we multiply both sides by 3? The 2 on the left times 3 gives me 6, and the 4 on the right times 3 gives me 12. Is the inequality still true? Is 6 less than 12? Yeah, it would seem that multiplying by numbers keeps the inequality true. But let's try some negative numbers just to be sure. Let's try multiplying this inequality by negative 3 and see what happens. The 2 on the left times negative 3 gives me negative 6, and the 4 on the right times negative 3 gives me negative 12. Is the inequality still true? Is 6 less than negative 12? Well, of course. Whoa, wait a second. Negative 6 is not less than negative 12. That is not true. What? In fact, the opposite is true. Negative 6 is greater than negative 12. So you have to reverse or flip the inequality to make the inequality true again? So why does this happen? Well, this is some cool math here. Think of the initial problem as a balance. 2 weighs less than 4, or at least in our gravity it does. So the 4 hangs down below the 2, pulling the scale down to its side. If we multiplied both sides by 3, we would still have the right side down low, since there would be 12, and the left side would be in the air with only 6. So what does multiplying by a negative do in this model? Think of it as reversing gravity. Instead of having the 12 hold down the scale, the negative 12 pulls up the scale because gravity is reversed. The negative 6 tries to pull up the scale, but it is not as powerful as the negative 12, which pulls up harder since gravity is reversed. So what does all this mean? Just that whenever you multiply or divide by a negative number, you must reverse or flip the inequality. But remember, this only happens when multiplying or dividing by negative numbers. So let's see if this works if we start with negative numbers. Negative 5 is less than negative 3. Yes, that's true. What happens if we multiply both sides by negative 2? We get 10 on the left and 6 on the right. Sure enough, 10 is not less than 6. We have to reverse the inequality so that it reads 10 is greater than 6. Okay, let's try this with dividing by a negative number. To start off with, negative 6 is less than negative 4. Yes, that is true. All right, so instead of multiplication this time we'll use division. Divide both sides by negative 2, and we get 3 is less than 2. But 3 is not less than 2, so we have to reverse the inequality. So it reads 3 is greater than 2. Okay, in conclusion, anytime you multiply or divide by a negative number, you must reverse the inequality. So let's go ahead and solve this inequality. How is x not by itself? It's being multiplied by negative 2. So what do? We divide both sides by negative 2. But don't forget that multiplying or dividing by a negative number reverses the inequality. If you are like me and forgetful, then you'd be better off if the first thing you do when you multiply or divide by a negative number is to reverse the inequality. If I try to remember after I use my brain to do the multiplication or division, that thought might not be there anymore. That's just the way I am. Once I get the inequality reversed, then I do the division. The 6 on the left gets divided by negative 2 to get negative 3. And the negative 2x on the right gets divided by negative 2 to get just x, which is what we want since we want to get x by itself. So there we have it. I'm done. No! I just broke the rule about leaving the variable on the right side of the inequality. I have to reverse the whole thing to get the variable on the left. Now I have x is less than negative 3. Okay. To check if the answer is right, I plug in a number that is less than negative 3, like negative 4, back into the original equation. 6 is less than negative 2 times negative 4, which means 6 is less than 8. That is correct. Okay, let's try this when x is divided by negative 2. To get x by itself, I need to get rid of the negative 2. Since x is divided by negative 2, I need to multiply both sides by negative 2. Right away, not to forget, I flip the inequality. Then I multiply the 6 on the right side by negative 2 to get negative 12, and the x over negative 2 by negative 2 to get just x. I don't want to leave the x on the right side of the inequality, So I flip the whole inequality around to get x is less than negative 12. Now I do a quick check with a number less than negative 12. I'll use negative 14. 6 is less than negative 14 divided by negative 2. 6 is less than 7. It's true. It checks out.